Good morning. I am D. Sengotian, Assistant Professor of Physics, SNS College of Technology, Coimbatore. Today our topic is classification of optical fibers. So we all know that fiber optics used for communication. So fiber optic materials basically defined by three basic types. That means materials, number of modes of propagation, and refractive index. So based on the material, we are using two different kind of materials. So glass and plastic. So in fiber optics, there are three types of layers. The first one is core, then the surrounding cladding, then finally protective skin. So if we are using glass core plastic cladding or glass core glass cladding or plastic core plastic cladding, depends upon the fabrication. These all are the basics of materials. The number of modes. So we are using single mode fiber and multi-mode fiber. So single mode fiber only propagates propagation of single light, that means single image or single videos are passing through the fiber optic cable. Then multi-mode fiber passing number of lights passing through the fiber optic cable. Then based on refractive index, that means two types of refractive index are available. The one is step index, then the other one is crater index fiber. Then based on the number of modes, single and multi-mode. So single mode fiber, the diagram shows that inner layer is core, then outer layer is cladding. So very small diameter core around 9 micrometers, then carry only one mode of propagation. That means only one light passing through the optical fiber. Then multi-mode have large diameter core compared than single mode. Then carrying number of modes inside the fiber optic cable by using multiple lights or images passing through the optical fiber used for transmission over short distance. So the diagram shows that first diagram only one light passing through the fiber optic cable, then second one shows that multiple lights passing through the optical fiber under the condition of total internal reflection, that means principle of fiber optic cable. Then based on refractive index, that means the step index fiber and multi-mode single mode step index fiber, then the multi-mode crater index fiber. The step index, it means very simple. Core and cladding refractive index moved by step. For example, N1 equal to 0.04, the N2 equal to 0.05. That means constantly moving from one value to another. That means N1, N2. So normally, if light passing through the optical fiber, it is required N1 greater than N2, then only light passing through the fiber optic cable under the condition of multiple reflection, and also required critical angles greater than incident angle, so that light passing through the fiber optic cable. So there are two different types of single mode fiber. That means single mode step index fiber and multi-mode step index fiber. Then crater index fiber, it means only availability multi-mode crater index fiber. So light passing through the fiber, for example, wave pattern. So these diagrams also shows that the single mode and step index fiber and crater index multi-mode crater index fiber. So compare than single step index fiber, crater index fiber, N1 value gradually decreases or increases, but in the step index fiber the value is constant, so step by step movement. But crater index fiber, the value is gradually increases or decreases, depends upon the fabrication. So N1 is increases or decreases gradually. For example, for initial stage is 0.9, then 0.8, 0.7, so gradually decreases towards N2. Then N2 is constant, so that these materials are called crater index fiber. So based on refractive index profile, comparison between step index and crater index fibers. So core having uniform refractive index, then core is a refractive index have vary in the parabolic manner. Then light rays propagating through the fiber are in the form of rays. Then the light rays are propagating into the fiber. In crater index fiber, it will be wave pattern. So these all are the comparison stats between step index step index fiber and crater index fiber. So numerical aperture attenuation. So attenuation, it means losses in optical fiber is more in step index, less in crater index fiber. So the light wave cannot transverse long distance, so in there without any losses. So air friction and other related losses. So fiber optic cable also producing some losses inside the cable, depends upon the efficiency of the fiber optic fabrication and also intensity of the light. So this diagram shows that propagation of light into the fiber. The inner circle shows core material, then outer circle it mean by cladding material, then covering buffer jacket. So N1 it means refractive index of core, then N2 it means refractive index of cladding materials. So these all are the basic definition of fiber optic cable. So under the principle of multiple reflection. So we are going to seeing in the other part of fiber optic principle, that means refractive index, numerical aperture and acceptance angle.